In this video, we'll be discussing increasing and decreasing functions. A function can be described as increasing, decreasing, or constant. Those are the only options. It's either going up, down, or staying flat. If x1 is less than x2 and f of x1 is less than f of x2, then the function f of x is increasing on the interval x1, x2. If x1 is less than x2 and f of x1 is greater than f of x2, then the function f of x is decreasing on the interval x1, x2. So those are our formal definitions of increasing and decreasing. When we get into really high level math and we're writing proofs, that formal definition is necessary. But at this point, I think that formal definition overcomplicates things. If your graph is going up left to right, then it's increasing. If your graph is going down left to right, then it's decreasing. There's no need to overcomplicate it at this point. And if it's just a horizontal line, well, then it's constant. That's all you need for this video and this course. Please note that when stating an interval that a function is increasing or decreasing, it must be described as an open interval, which means that there are parentheses on both ends. And I'll explain a little bit more about that in a minute. So let's take a look at this graph below. We want to state the intervals on which the graph is increasing, decreasing, or constant. And all you're doing is looking, does it go up or down as we go from left to right? And I typically start on just the left side of the graph and move my way to the right. Don't pay attention to the arrows on the ends of the graph when you're doing this. It can cause you to get the incorrect answer. So let's just start on the left part of this graph. We want to look at what our graph is doing as we go from left to right. So as we proceed from left to right, is our graph going up, down, or staying constant? It's going down from left to right. So that piece of the graph is decreasing. Now we want to actually write down the interval of x values that represents that portion of the graph. Since there's an arrow on the left that tells us that our graph continues forever, so our very first x value where our graph is decreasing is going to be negative infinity. And then what's the x value when this piece stops decreasing? Well, that happens right here, and the x value is negative 2. So that first shaded portion of the graph is decreasing, and that's the interval of x values, negative infinity to negative 2. Now let's take a look at the next portion of the graph. Is this going up or down as we go from left to right? As we go from left to right, the graph is going up. That means that the graph is increasing on this interval. We now want to write the interval of x values that represents that shaded piece. The very smallest x value right here when we start increasing is negative 2, and the largest x value on this piece right here, negative 1. We are increasing on the interval from negative 1 to negative 2. This is a great time to talk about why we always use parentheses on the ends of our intervals. Take a look right here. This is where our graph is switching from decreasing to increasing. And that switch happens at x equals negative 2. Since that's our change of direction point, we just call it neutral. I don't want to claim it as either increasing or decreasing because that's the spot where it changes from one to the other. That's why we don't include the endpoints when stating these intervals. All right, let's move on to our next piece. So our next piece right here, as we move from left to right, is our graph increasing, decreasing, or is it flat? Well, here it's flat. That means that our graph is constant in that interval. And now we want to state the intervals, the x values for that portion. The smallest x value, well, it starts right here at -1, and then our largest x value in this interval, +2. The graph is constant on the interval -1 to 2. Moving to our next piece. As we go from left to right, our graph is going down. So we are decreasing on this interval. Writing the x values for this interval, it starts at +2 and ends at +4. So you'll notice that we're now including a second piece of interval notation with our decreasing intervals. So just like domain or anything else, you always connect two pieces of interval notation with a union symbol. Looking at the next piece of our graph, it's going up from left to right. That means our graph is increasing on this interval. We want to write the x values of this interval in interval notation. The smallest x value is +4, and the largest x value is +6. Again, you'll notice I put a union symbol in between these two pieces of interval notation. The last piece of our graph, it is going down from left to right. This interval, our graph is decreasing, and we just need to write the x values. This piece of the graph starts at the x value of +6, and the arrow on the end pointing to the right tells us that it goes on forever all the way to +infinity. Our graph is increasing on the intervals -2 to -1, union 4 to 6. It's decreasing -infinity to -2, union 2 to 4, union 6 to infinity. And the graph is constant on the interval -1, 2.